Modern medicine treats the human body like a chemistry set. We pour in compounds and hope the molecules react the way we want them to. But this chemical approach has a hard limit. When tissue permanently dies, no drug can bring it back. And when we try to physically connect wires to the nervous system to bypass that damage, the body's immune response encases those metal implants in thick scar tissue, a biological defense mechanism that cuts off the electrical signal entirely. A company called Science Corporation is taking a different route. Instead of trying to solve biology with chemistry, they are treating the human brain and body as an information processing system. They view our sensory inputs and motor outputs as a human API. An API, or Application Programming Interface, is the set of protocols that allows different pieces of software to talk to one another. By viewing the nervous system as software, they can bypass damaged tissue and rewrite the code.
By abandoning cellular chemistry in favor of high-bandwidth neural engineering, we can reintroduce lost information straight to the brain. This overcomes biological degradation that we previously considered permanent. We are already seeing this work in the eye. Millions of people lose their sight to geographic atrophy, a condition where cells in the central retina die off, leaving the patient functionally blind. To bypass this damage, science created the Prima retinal implant. It is a microscopic square measuring 2 millimeters wide and 30 microns thick, which is roughly half the width of a human hair. When top-layer photoreceptors die, the Prima implant slides underneath. Its 400 electrodes directly stimulate surviving bipolar cells, sending signals to the optic nerve. Simultaneously, camera-equipped glasses project near-infrared light into the eye, powering the chip and transmitting visual data. In clinical trials involving 38 blind participants, using optogenetics, these light-responsive cells are controlled by precise flashes of micro-LED light, triggering specific neurons with high resolution. Once implanted on the surface of the cortex, these engineered neurons grow and form natural synaptic connections with the host brain. They act as a living biological bridge between the machine and the host tissue. By interacting with living cells instead of a foreign metal probe, it avoids a defensive scarring response. This achieves a stable, high-bandwidth connection without destroying the brain tissue. If we can successfully rewrite the data in our eyes and our brains, we are still left with one final biological limit: the inevitable decay of our internal organs. To address this, science is developing the Vessel platform. It is a miniaturized, autonomous machine perfusion system designed to sustain organs indefinitely outside the biological body. Hospitals currently use systems like ECMO, extracorporeal membrane oxygenation, to temporarily pump and oxygenate blood. Vessel is designed as a destination therapy, a permanent mechanical circuit that makes the failure of a heart or lung survivable by making the body's parts swappable. This convergence leads to the 2035 event horizon. This is the projected point where ultra-high bandwidth neural interfaces and artificial superintelligence, software that vastly exceeds human intelligence, fully unify. At this scale, the engineering objective shifts from medical repair to cognitive enhancement. By combining mechanical life support with a high-bandwidth bridge to the cortex, we gain the technical infrastructure to eventually move consciousness beyond the physical body. If the brain is a computer and the body is a replaceable power supply, then biological death becomes a technical problem rather than an inevitability. If these trajectories hold, the first humans capable of living 1,000 years have already been born, marking the transition from a strictly biological condition to a new, sentient condition.